Good morning, everyone, and welcome to the webinar entitled Firestopping Engineering Judgments. My name is Christina Larkin, and I will be one of your moderators, along with John Zalepka, who is our Training and Development Manager. We would like to take a moment to review some housekeeping items before we start. All attendees will be muted during the webinar. We will be disabling the chat feature during this session. Questions can be sent in the Q&A section at the bottom of your window. We will be gathering your questions during the webinar and will hold a question and answer discussion at the end. We will be reporting AIA credit for those of you who attend at least 75% of the live webinar. If you have an AIA number and did not give it upon registration, please send it to webinars@stifirestop.com. If you are not a member of AIA, STI will be sending certificates of attendance for you to self-report to whatever agency you wish. We will also be sending a recording to all who registered. Please allow 7 to 10 business days for the generation of certificates and recording.
Thank you, Christina. Firestopping engineering judgments, or EJs, as they're commonly referred to as, show up on construction projects often when field conditions differ from the original intended design. While EJs may be unavoidable at times, upfront planning during pre-construction meetings and coordination between the trades can minimize the number of EJs required. Our presenter today is Keith Sanford, STI's Western Regional Field Engineer, who will be walking us through the critical elements needed to obtain an engineering judgment, providing us with some guidelines and resources for doing so when necessary. And with that, Keith, the floor is yours.
Thank you, John, and thank you, Christina. Hello, everyone, and thanks for joining us today. So my name is Keith Sanford, the Senior Field Engineer with Specified Technologies, Inc., also known as STI. John will tell you more about STI at the end. But about my Firestopping short codes required consist versus approved materials back in the late 80s. And I've been in the firestopping business ever since. Like yourselves, training installers on site, inspecting installations, troubleshooting, working with building officials, etc. And I've done this all over the world during the past 30 years, but I certainly don't know everything. Plus, each project is different, and materials and methods continue to change and evolve, so I never stop learning. As Christina mentioned, this is a AIA-approved educational seminar. And for you architects who are AIA members, you'll receive 1 learning unit for today's presentation. Presentation is copyrighted, but will be recorded and posted on our website for future reference. Here's the agenda for today. So first of all, we'll cover the premise of firestopping systems. It's the basis for the whole presentation. We'll define what are engineering judgments, talk about the most common applications for EJs, who issues them and how long do they take, the process for obtaining an engineering judgment, and do they need a third-party engineering stamp? We'll go over the regulations, the acceptance, guidelines, and oversight of EJs. And we'll go through, I have 4 real-life examples at the end, and then John will jump in and talk about how STI can help. First of all, firestop systems deter the passage of fire, smoke, hot gases through openings in walls, floors, and roofs for through penetrations, membrane penetrations, joints, blank openings, gaps, and other voids. These systems are required by building codes to be tested and rated as part of an assembly in accordance with their approved test standard. The main test for penetrations is ASTM E814 with the expanded UL 1479 version, giving the additional options of W and L ratings. Those are water and air leakage ratings. For fire-resistive joints, ASTM E1966 provides fire and temperature resistance, whereas UL 2079 does the same and again provides the option for air leakage and water resistance. For curtain wall or the perimeter fire containment, ASTM E2307 is the main test standard, but E119 is also allowed under a certain code exception. For that one, there is no UL version. If you're in Canada, then ULC S115 applies. And if you're joining us from outside of North America, you may be using British standards like BS 476 Part 20, maybe European norms, EN 1366 with various parts, or whatever your country or local jurisdiction has adopted. The basic principles of fire stopping are the same around the world. These are examples of common fire stop applications, including pipe penetration, curtain wall joint, that's the gray colored sealant there, and head of wall joint. Fire stop systems use a variety of specially formulated, independently tested fire resistive products for sealing penetrations and joints in fire-rated construction against the spread of fire and smoke. The emphasis here is on systems. So fire stop products are one component of a system. But fire stopping certainly is an important part of fire containment and life safety. So who tests fire stop systems? Fire stop system designs are tested and listed by independent testing agencies. In North America, UL, ULC, and Intertact are the most common, but FM Global also has listings, and Southwest Research Institute tests fire stop systems as well. Most have their own listings published online. I'm sure you've seen some of those if you're into the fire stop business at all. And then if you're in the UK or other countries or using British standards, Warrington Fire is very well known, and there are many other relevant testing agencies depending on your location. So what is a tested or listed system? It refers to a penetration or joint assembly which is rated per its corresponding test standard. So shown here is the top portion of a simple pipe penetration system, and the written description is summarized on the left-hand side. All elements of the fire stop system, including the assembly into which it's installed, comprise a specific and inseparable unit that must be utilized as such. Right? The specific elements of each design become integral to the listing. In this example, UL system CAJ 1240 describes all the elements of a metal pipe penetrating the concrete floor or wall. So in this one, it's a minimum 2.5 inches of concrete floor or wall or a CMU wall. There's a steel sleeve that's optional. The pipe is a maximum 30-inch diameter metal pipe. Annular space is 0 to 2 inches. It means the pipe could be touching one side and no more than 2 inches on the other. There is 2.25 inches of mineral wool packed into the opening here and topped off with a 1/4 inch of fire stop sealant. So building codes require fire stop systems to be installed as tested or listed by qualified test labs. So these two sections of the International Building Code are examples. Through penetrations shall be protected by an approved penetration fire stop system installed as tested in accordance with ASTM E814 or UL 1479. And under joints, it states installation, installed in accordance with the manufacturer's installation instructions and the listing criteria. So simply put, install fire stop systems the way they were tested and listed. Just follow the instructions. But we can't test everything. Right? There's no way to anticipate and test every condition that may occur during a construction project or the life of a building. Putting it nicely, unexpected things happen. Construction is a complex process that requires an incredible amount of coordination and communication. It's not perfect. So, and we all know what happens during, let's say, renovation of old buildings. When walls and ceilings are opened up or removed, there's almost always surprises. So in addition, New products and materials are introduced every year. New wall and floor assemblies are tested and listed. New construction methods are developed. Codes and standards change, et cetera, et cetera, et cetera. So what happens when field conditions differ from tested systems? So in this example, a hole was cored in one place, the wrong place, as it turns out. So a second hole had to be cored. And now the opening looks like a figure 8, and it may no longer meet, the parameters of the UL system that was chosen for this application, because the annular space, the distance between the conduit and the edge of the opening, may exceed the maximum allowed. So now what do? Well, first of all, try to find a tested system that does satisfy the field conditions. You can look on UL's website called Product IQ, or Intertek's Directory of Building Products, manufacturers' websites, or contact a manufacturer. In the case of the figure 8 example, there are systems available for larger openings, but on almost every job site, situations will occur during construction for which there are no tested systems. So step 2, if no tested system exists for the condition, then either modify the condition or request an engineering judgment. When I say modify the condition, I mean something construction related. For example, reduce the size of the opening, or extend a wall up to a hard ceiling, maybe move a penetrant, or a myriad of other things. But if modifications are not possible or practical, then an engineering judgment can be requested. There are several different definitions of engineering judgment out there. This one is UL's definition, which can be found on their website. And their definition is broader than just Firestop systems. It addresses any fire-resistant design, assembly, or system. So you're looking at the yellow highlighted part here. An engineering judgment is a method or process used to resolve field needs when a tested design, system, or assembly is not available. Right? It goes on to say that it should be done by somebody knowledgeable. It should be acceptable to the code authority and be site-specific. The International Firestop Council, or IFC, also has a definition, which you'll see on the next slide. In fact, IFC has a multi-page guideline for engineering judgments. But first, if you're not familiar with this organization, it's a not-for-profit association of manufacturers, inspectors, and users of fire protected materials and systems, and it's an excellent source of Firestop information. The IFC has a document available on their website called Recommended IFC Guidelines for Evaluating Firestop System Engineering Judgments. Within these guidelines is a definition of engineering judgment. To paraphrase, it says, when field conditions differ from original design, propose alternative methods, and sometimes referred to as engineering judgments, or EJs. And there are other terms, like in Western Canada, EJs are also known as TJs, or technical judgments. We'll get to that. IFC also has EJ guidelines specifically for perimeter fire barrier or curtain wall systems, air ducts, and grease ducts. However, for the purpose of this webinar, we're going to focus on the guidelines for Firestop systems, which include penetrations, joints, and perimeter fire barrier. I like to think of engineering judgment as just a fancy term for alternative design. So it's really quite simple in concept, but it's important to understand how they're done and by whom, as well as the regulations that affect them, because they're an important part of fire stopping, life safety, and liability. Now let's talk about building codes for a moment. Although codes require Firestop systems to be tested per approved standards, alternative designs are allowed. Codes are not designed to restrict the use of any material or design or method, but alternatives must be approved by the building official. Generally, alternatives are discouraged in favor of tested systems, but there are situations where they can't be avoided. Take CLT construction, for example. CLT stands for cross-laminated timber, also known as heavy timber. And CLT construction is allowed by the International Building Code for high-rise buildings. However, there are no tested or listed Firestop systems available yet. Fire tests are in progress by STI and others, but it's very challenging compared to using concrete, masonry, and drywall. The UL is busy developing a category for this, But any fire stop systems used in CLT construction have to use EJs or alternative designs because there's no choice. Now, if you look at IBC section number 104.11, it basically states that alternatives shall be approved where the building official finds that the proposed design is satisfactory and complies with the intent of the code, and that the material, method, or work offered is not less than the equivalent of that prescribed in the code. In Canada, alternative solutions are also allowed by code, the National Building Code, or NBC. Western Canada tends to lead in code enforcement. And if you're in Alberta, like Calgary, Edmonton, and so on, then you're familiar with StanData. StanData is a separate organization which publishes informational bulletins, guidelines, and reports. And in this case, there is one for Firestop engineering judgments. So the BCB number 19 BCB 005 provides guidance for engineering judgment for Firestop systems as an acceptable solution under the National Building Code. And that's where the term technical judgment came from, or TJ. Now, if you deal with the British or European or other codes, you'll find that alternative systems are allowed there as well. I mean, it's just good practice to use tested systems whenever possible, but allow alternative designs when necessary under certain guidelines and approval by the authority having jurisdiction. So who issues EJs? Firestop manufacturers typically issue engineering judgments upon request, and there's no charge for this. As far as I know, nobody charges. It's part of the business. However, only qualified technical personnel should issue them. EJs may also be issued by fire protection engineers, knowledgeable registered professional engineers, independent test agencies that provide listening services for Firestop systems like UL or ULC. But some architects are also very knowledgeable about fire protection and issue alternatives for various elements of construction on a regular basis. But it's best with Firestop to at least involve the manufacturer because manufacturers know most about how their products behave in fire, as well as the full assemblies. But, knowledge and experience are extremely important in order to design EJs with confidence. Issuing an EJ is the equivalent of stating that it is expected to pass the stated rating if tested per the reference standard. So salespeople, for example, should not issue EJs. Most manufacturers have qualified technical people who handle them on a daily basis. How are EJs designed? So the bullet points are shown here are based on the IFC guidelines mentioned earlier, which most manufacturers follow. So number one, you start with tested systems. You're looking for something close to what the application is in the field. And then you'd use interpolation or extension of existing data there, existing systems, which are similar in question. Additional knowledge and test data are often used too. So not all tests, become systems. There's a lot of test data out there that can be used in certain situations in order to design an EJ. You should use accepted engineering principles, fire science, fire testing guidelines, and of course, good judgment. Full knowledge of the elements of the construction to be protected. That means the penetrance, the walls, the floors, etc. And understanding the probable behavior of a system under fire conditions per the appropriate fire test standard. So, there's a lot to know and understand in order to design a proper engineering judgment. For example, there's a big difference between steel pipe and plastic pipe. In addition, PVC pipe burns very differently than polypropylene. And electrical cables with copper behave very differently in fire than fiber optic cables. And a standard 2-hour gypsum wall performs very different than a shaft wall because a gypsum shaft wall is not symmetrical. It has to be tested from both sides. So people who design EJs have to understand all this and have the experience to design safe, effective systems. What do engineering judgments look like? So when you get one, it's going to look very similar to a tested system, but it should be clearly identified as an engineering judgment. They're normally presented as one or more illustrations with a detailed description, just like a Firestop system. But illustrations are not required. Okay? Some may be in written form only. There's no rule that says you have to have a drawing. EJ should also include clear directions for the installation of the system, include the date of issue, an authorized signature, an issuer's name. cite the tested systems upon which the EJ was based and have proper justification, identify the project name and location as well as the company to which it was issued, provide complete descriptions of all the critical elements for the Firestop configuration. All right, so this is an example EJ that was done for a large opening with multiple insulated pipes. And this is a 2-hour shaft wall. There are tested systems for insulated pipes through shaft wall, but they're limited. In addition, these were steam pipes, and the insulation was up to 4-inch thick glass fiber. So at the top, you can see a drawing, the fire rating, 2 hours in this case, and the EJ number, which has been hidden. The main reason for the EJ in this case was the type and thickness of the insulation. So glass fiber insulation breaks down in fire, and if it's not fire stopped properly, will allow fire to spread through the wall. So fire stop collars were required around each pipe in this case, which expand during fire and close the gaps left by the consumed pipe insulation. The middle portion of the EJ has all the details. So this is the written description. It's got the wall assembly, the penetrant, the packing material, sealant, steel cover plate in this case, and wrap strip with steel collars. All the details are here. And in the lower section, it's an information block. So we got the information including project name and location, the EJ designer, the responsible party, that's usually the contractor or architect, a signature, date, and the reference systems. If you ever wondered which applications result in the most EJs, here's your answer. So this chart shows the most common types of EJ requests done by STI in 2020. Other full-line suppliers of Firestop may have a similar distribution. Of the thousands and thousands of EJs issued last year, about 59% were penetrations, 28% joints, and 13% curtain wall. But if you ask our engineering services team about EJs, they'll tell you that joints and curtain wall systems take the most time. They tend to be the most complex and difficult situations to deal with. So how do you submit a request for an EJ? Well, most manufacturers have a standard form, usually online. However, each company is different, so just ask what their process is. A standard form acts like a checklist to help you collect all the required information. In a minute, I'll show you what's required for each type of application. But any additional information you can provide, such as plans, photos, sketches, or notes, help technical personnel a great deal in understanding a situation and providing accurate EJs that reflect real field conditions. This is just a snapshot of the beginning of an online EJ request form. At the end of the presentation, John is going to show you STI's website and do a live demo. So what information is required to request an EJ? So first of all EJ requests must have the name and address of the project because every EJ is project specific. It cannot be reused for a different project without submitting it first for review with respect to the project in question. So all EJ should also note the responsible party, like architect, engineer, contractor, building owner in the case of a maintenance work or remodeling. Now for penetrations, you need the type, thickness, and fire rating of the wall or floor penetrated. Now, in this case, you can see the photo. This looks like a standard CMU block wall. Penetration type and size. So you can see multiple conduits going through here. There's maybe a dozen of them or so. They look about 1 inch, but all the details on that need to be captured. Type and size of the sleeve, if any. Usually sleeves are just round and have one pipe or conduit, but you could have a rectangular, I suppose, steel sleeve. But if there is, you need the type and size. Annular space. You need to know the minimum and maximum space between the conduits in this case, and also the min and max between the edge of the conduit and the outside of the opening. And then note if there's any special conditions, like maybe a blank opening, there's no penetrant, or access to one side only. That's fairly common because you either have a shaft wall and you can't get to the other side, or maybe it's a mechanical room on the other side and there's equipment in the way, whatever. Maybe the pipe coupling is in the plane of the wall, which makes the diameter of the pipe bigger. You might have an angled penetrant, or you might need equal F&T ratings. Sometimes that happens when you have penetrations through a floor and it's not contained in a wall. The information required for joints is slightly different from penetrations. Starting with the third bullet there, first we need to know the type of joint. Is it head of wall, wall to wall, floor to floor, floor to wall, et cetera, et cetera. We need to know the type, thickness, and fire rating of both intersecting walls or floors. You need to know the joint width. And again, special conditions. Is there movement involved? Did the structural engineer say you need plus or minus half an inch movement, for example? Again, access to one side only. Then maybe there's steel support angles at the top of the block wall for structural support. Maybe there's a deck or the beam going through that's fireproofed. And all these things should be noted. And for perimeter fire barrier EJs, we start with the exterior wall type. Is it aluminum frame with glass? Is it steel stud, precast, GFRC, or other? We still need the floor type, thickness, and fire rating, just like the others. Joint width, which is the distance from the edge of the slab to the framing, which of course you have 0 if the framing is sitting directly on the concrete. The windowsill height is important. And when it comes to special conditions for curtain wall, movement may be a factor, static or dynamic. Where the anchors are mounted is important, top or edge or bottom. Maybe it has a steel backpan, could be a cantilevered track. Maybe there's a penetrant coming through the joint for lighting or shades. Or maybe there's a specific brand of curtain wall insulation or safing. So how long does it take to get an EJ? If you're doing it for the first time, you may have some expectation in your head, but it depends on many factors. The thing is, when you're in the middle of a construction project, EJs can cause delays if they're not handled efficiently. So STI sets the bar in the industry with typical turnaround time of 24 hours or less. In fact, many are turned around in just 4 hours or half a business day. However, some times of the year are busier than others. For example, March and April tend to have the highest demand for EJs. But number one, definitely provide the clear and complete information. That is the biggest delay of getting an EJ back. The complexity of the application has a bearing on the time. Efficiency of the manufacturer's process or technical personnel. The volume of EJs at the time of request. Okay, they're high right now, but we're still cranking them in 24 hours for the most part. Number of changes or corrections required, if any. Sometimes you'll get an EJ back and you look at it and there's something missing. And maybe you forgot to tell them something. Maybe they overlooked a small point. Going a little bit back and forth does happen sometimes. And there's other factors. But, when you make a request, try to put yourself in the shoes of the person who will be designing it. They don't have the advantage of being on site. So they rely entirely on whatever information is provided. And again, the use of details, photos, notes, hand sketches are very helpful in understanding the field conditions. And it's critical in order to get an EJ that meets your needs and satisfies the building official. Now, this question I get typically from someone who ran into this requirement for the first time. Do EJs need to be stamped by an engineer? Well, it depends entirely on the jurisdiction. Generally, the answer is no. But the ones you see listed here, we know have done this, and there's others. This is by no means an exhaustive list. So if you're in the New York City area, only select high-profile projects and certain applications, maybe curtain wall, have been known to have the requirement of getting an engineering judgment stamped. The Port Authority of New York and New Jersey is the same, sometimes for a complex application, but it's the exception, not the rule. If you're in Florida, in Miami, Dade County, very often you'll need to get an EJ stamped. Orlando, Orange County, Florida, about a quarter to half the time, you're going to need a stamp as well. Walt Disney World, all EJs need to be stamped. They have strict standards, mouse rules, as they say. Clark County, Nevada, Las Vegas. If you're working on the Strip, where all the big hotels and casinos are, all EJs need to be stamped. If you're in the suburbs like Henderson or somewhere, not necessarily. That depends on the inspector. If you're in California, OSHPD, who is California's healthcare overseer, and the California State Fire Marshal very often require engineering judgments to be stamped. If you're in the Chicago area or somewhere in Illinois, the Illinois Department of Health requires at least commentary by an approved fire protection engineer on every engineering judgment. Mecklenburg County, North Carolina, that's Charlotte, all EJs have to be stamped and use a specific form. And if you're in Canada, the Greater Toronto area, my colleagues up there say around half the jurisdictions are now requiring it. And in Western Canada, like Alberta and BC, very much a growing trend in the larger cities. So if you're wondering why jurisdictions do this, the reasons vary, but the predominant theory is twofold. One, to discourage the use of EJs, and two, lack of trust in those who provide them. Now, by that, I don't mean they don't trust manufacturers in general, not at all. But it only takes one person who's not qualified to issue an EJ and submit bad ones and destroy the trust in all EJs. And that is a classic case of what has been reported that happened in Mecklenburg County, North Carolina. And that's why today all EJs have to be stamped and use a form. If you're wondering about the cost, I'll share with you our experience. It totally depends, of course, on which firm or which engineer is doing it, as well as the complexity of the application. But in our experience, it costs around $500 to $700 in the US per EJ and about $800 to $1,000 Canadian. But I've known some to top $1,500 or more. As an example, imagine a large project with 100 EJs. That's at least an additional $50,000 spent on the review and stamping of EJs. And some of you may remember the City Center project in Las Vegas back in, it was built between 2005 and 2010 roughly. And at that time, it was the single largest construction site in America at a final cost of over $9 billion. So there's 4 high-rise hotels and multiple casinos, restaurants, shops, etc. In fact, some of you may have stayed in one of the hotels there, like Aria or Vidara. Well, that project had at least 400 EJs at a cost of over $200,000. Sometimes I get asked, well, why don't manufacturers just stamp them? Well, the main reason is that a manufacturer is not considered an independent third party. But when needed, we can refer you to engineers who provide review and stamping who are licensed in all 50 states and throughout Canada. Some of them are licensed internationally as well. There are some authorities having jurisdiction who do not allow engineering judgments for new construction, period, at least during the design and permitting phase. Now, contrary to what you might think, most building officials are pretty reasonable. And I'm sure we all have stories of someone who wasn't, but most are pretty agreeable to reasonable solutions when problems occur during construction. But for new construction, one reason some jurisdictions stopped accepting EJs is that too many plans were being submitted for new buildings with dozens of EJs before construction even started. Now, this goes well beyond Firestop. It's not a Firestop issue, it's an EJ issue. But they grew tired of that, and who can blame them, right? Their job is to enforce the code. And in many cases, the code was being ignored and substituted with less expensive alternatives. So from that point of view, it's easy to understand a building official's position. EJs are meant for situations where there is no tested assembly. And theoretically, that should only occur during construction, where all kinds of unexpected things happen. But nothing's that black and white, and every project and jurisdiction is different. All right, now let's look at some real life examples. First of all, this is a headed wall joint. And this was a recent application at an existing prison where the authority having jurisdiction was very strict on code enforcement. The wall was a shaft wall, so there was only access from one side, and the joint was concealed by a continuous steel angle at the top, also fireproofing. You'll see that angle in the next slide. So you might look at this and think that's enough for a 2-hour rating, but there's no tested system for it, and the area above the wall was concealed. So, but I will say this is a good example of good notes and a clear drawing. But when you look at this, it's very easy to understand the basic situation. Here's some additional information that was provided, which shows the steel angles at the top of the wall. So those were installed for structural connection and inmate security. This was kind of a dark photo, but if you look closely, you get a sense of the condition they were facing. So some missing fireproofing was noted, and the head of wall joint is also covered with spray applied fireproofing. The goal here was to provide 2-hour continuity of the wall all the way up to the underside of the roof. The solution in this case, which was a collaborative effort with the architect and the contractor involved, was a gypsum shaft wall construction with fire stopping where it met the wall and the underside of the roof. Here it is in more detail. So first of all, at the bottom there was a simple fix. It was just a fire stop sealant between the horizontal gypsum boards and the block wall. At the top is a little more complicated. We call it a sandwich type system. Had to install this from one side, and we also refer to it as stuff spray, stuff spray. So there's mineral wool backing and fire stop spray above the shaft liner board, and then again above the double 5/8 type X gypsum. So you stuff it with mineral wool, you spray it, you stuff it with mineral wool, and you spray it. So this system took some back and forth to get all the details correct and satisfy the fire marshal, and also be confident that it could be constructed correctly. Number 2, so this was a perimeter fire barrier condition, and it's really a relatively simple condition once you understand it. You're looking at an elevation view or the side view of the wall here. It's an exterior window wall with glass fiber reinforced concrete spandrel panels. And the gap between the edges is between the edge of a slab and the wall, which is over 8 inches wide, was filled with fire safing or mineral wool. And this looks pretty good overall, but there were 2 issues. One, there's a metal panel fastened to the GFRC panel. It's filled with mineral wool, but that's not part of any tested system. And 2, although there's fire safing in the joint between the edge of slab and metal panel, the density and compression were not called out, and there's no fire stop sealant for smoke as well as fire and hose stream resistance. So the solution in this case was essentially to add fire stop spray over the fire safing. The next slide shows it in more detail. A minimum of 4 inches of mineral wool was compressed in the joint, compressed 33%, between the edge of slab and the metal panel, and then sealed on top with a specific fire stop spray. Example number 3. So in this situation, there's a 2-inch diameter steel conduit penetrating one side of an existing wall made of lath and plaster. The wall consisted of 7/8 inch plaster on metal lath on both sides for a total thickness of 5 inches. The building was an older hospital built in the 1950s, just before drywall started replacing lath and plaster as a quicker, easier installation option. And since modern day fire testing didn't really take off until the late 80s, there aren't any fire stop systems using plaster walls. However, that doesn't mean plaster doesn't have any fire resistance, because it does. In fact, the IBC has a table of fire resistance of various walls and partitions, including plaster. If you're interested in learning more about that, refer to IBC sections 719, 720, and 721. The person who submitted this request cited that code, which supported a 1-hour fire rating for this type of wall construction. And based on our experience and similar tests with drywall, we were able to provide an engineering judgment. So this one turned out to be a very simple solution using fire stop sealant around the conduit. Okay, in this last example, this was, again, a perimeter fire barrier, a curtain wall. And this building had some curtain wall conditions that did not conform to any tested system due to the angled walls and some corner designs. And code enforcement was very strict. In fact, the building official was not accepting any EJs. But we tried anyway because we were confident we could provide a design that would pass 2 hours. Here's an elevation or side view of the angled wall passing by a concrete floor. And here's a plan view of a step back corner, as it was called. So you're looking down on a typical floor here. The darker shaded part is the joint between the floor and the curtain wall. There were also two different types of glazing systems planned for this project. So this was a draft of a solution looking down again on a typical floor corner. At this point, we were still collecting information and going back and forth on a proposed design. You can see some of the redlining on the drawing. We felt the condition was reasonably similar to other tests that have been done. So as a group, the general contractor, architect, curtain wall manufacturer, and STI proposed an EJ and made our case to the building official to avoid having to do a test, but to no avail. So there was no choice in the end but to do an actual fire test because the project was too far along to change the design of the curtain wall. So we designed a test and moved forward. This was the curtain wall construction detail, and you can see the step back corner at the top, and then the angled wall. So testing a curtain wall system is a long, expensive process to complete. So this part of the project was delayed for months while the test was being done. You can see all the different steps involved in doing such a test. You have to start out with some agreements between parties. There's concept and design. We had to get the approval of the authority having jurisdiction because we didn't want to do the test and then have them say no. You got to plan and order the materials, install the system, wait for it to cure, witness the test, write the reports, and then publish the system. If you've never seen a curtain wall test, this is what it looks like. It's a two-story apparatus with two burners. The interior burner is lit first, followed by the outside burner after 5 minutes. Now, in this case, the goal was a 2-hour rating, but we let it go much longer for additional data and observation, and this turned out to be a very successful test. In the end, a new UL listing was published, as you can see here. It might not be ever used again, but if the same or similar conditions appear on a future project, it'll be a very good reference. Please understand that this was a very rare case in which a test had to be done. We most certainly can't test every situation that comes up. The cost and the time required are prohibitive. Nothing would ever get built. One last point, then I'll turn it over to John. So currently, there's no oversight of engineering judgments. Each manufacturer is responsible for its own process, and that won't change. However, UL, together with manufacturers and others, is in the process of creating a new program that would audit those who issue engineering judgments, or technical evaluations, as UL is going to call them. The goal of the program, as I understand it, is to create more validity and acceptance of EJs throughout the industry. If a manufacturer chooses to participate, then a management system would be developed by the manufacturer, if one doesn't already exist, and periodically audited by UL for conformance. In addition, UL will randomly select EJs for fire testing to prove their validity. The people who issue EJs will be required to have a certain level of education and experience and pass a written exam. They will also have to be recertified every 3 years. In return, that company can promote the fact that their EJ process is UL certified, or whatever the actual terminology will be. This concludes the educational portion of the presentation. And now I'd like to turn it over to John to show you how STI can help with Firestop systems and engineering judgments. I'm going to stop sharing my screen and we'll turn it over.
All right, Keith. Great job there. Do we see the map up there?
Yep.
Perfect. All right. So just want to let everybody know, Specified Technologies, or better known as STI Firestop, we are a leading manufacturer of innovative cost-effective fire stop solutions for the building, construction, and maintenance. We're the only full-line supplier of fire stop products and systems in the United States whose business is fire stopping, so we're very focused. Our global headquarters is in Somerville, New Jersey. We're about an hour west of New York City. So when we open back up, we'd love to have you in for one of our trainings at corporate headquarters. But we've been around since 1990, so for over 30 years. We've now developed into a true global organization, as you could see from some of our warehouses and our reach throughout the globe. So here's our engineering service team. Keith went through kind of the whole process of how it works, and we get it done in 24 hours or less. We have over 250 years experience between the people that you see sitting on the screen there. They're available Monday through Friday from 7 a.m. to 7 p.m. They are available by email, techserve@stifirestop.com. That's techserve@stifirestop.com, or by visiting our website, much easier. So you have that up there on the screen, www.stifirestop.com. And if you visit there, you can actually chat with an engineer during the business hours of 7 a.m. to 7 p.m. Eastern time, and you can get a quick answer, and they'll let you know if you need a system, which we always recommend, and we'll show you how to find those first before you need an engineering judgment, but they'll let you know that right away. So if you're on a job site, you don't have to worry about getting an answer. You can get one pretty quickly. So here's how you would request an EJ. We have a QR code up there, and since this pandemic, a lot of people are very familiar with the QR code. So if you grab your phone, snap a picture of that, that'll take you over to our Access STI account. Now, we recommend that you register for an account, because if you ever do need to request an EJ from STI, this will store it in your account. Now, you can request an engineering judgment as a guest. I'll show you how to do that in a little bit. But if you are logged in and registered, it will save it into your account, and it will help you to put it into your submittal packages. And it will also give you access to a lot of the other tools that you see on the screen there, which is System Search and Submittal Builder, which we'll show you in a second. We also have a ton of guide specs. We do offer guide review services. Keith does that for us as well. And there's all types of BIM objects and different Firestop clash management software that's available on there as well. So, take a look at Access STI. You won't be disappointed. So I'll kind of show you what that looks like now. Hopefully this works here. There we go. So this is our main website. And stop me, Keith or Christina, if you're not seeing the main website. But this is our main website, stifirestop.com. This is kind of where you would want to start. If you didn't follow that QR code, this will give you Access STI and where you would go to find Firestop systems. So again, we always recommend that you start by trying to find an actual system. Here's that chat function down in the bottom right-hand corner. If you kind of click that, you can be chatting with an engineer within 60 seconds. They usually pick up your question there. But you can probably get a lot of your questions answered just by visiting this website and looking for your Firestop systems. Now, I happen to be logged in already, so you'll see I'm here. It's welcoming me, John. It's good. It actually autofills a lot of things for the submittals. I've made 476 submittals over the course of my time here at STI, so they're all stored there, so I can grab a historic submittal very easily. But this is how you would find a Firestop system. So if we were just looking for a typical through penetration or joint, we would just start here, and I'll just select penetration. And what's going to happen is our system search will begin to narrow down our systems. We have over 1,400 systems, including joints, 915 of them for penetrations alone. So each time we select a different item here, so a barrier, if we choose floor, then 915 becomes 460. Now, once we put the penetrating item through there, if we choose just a metallic pipe, now we're down to 156. So now where engineering judgments come into play is, let's say we have a steel pipe that's huge. Maybe it's 36 inches, but we've only tested up to 30 inches. So we would find the 30-inch system here, CAJ 1240, and then we may do an engineering judgment or request a judgment based on our 36-inch steel pipe. And if that is the case where you find that, okay, I've gone as far as I can here, I can't seem to find my 36-inch pipe, then you would just click right here, engineering support. and this is how you would go about requesting your engineering judgment. So I am not signed in now once I get to this sheet here, but you could sign back in where it will save in there, but this is how you would do it as a guest. So you would put that penetration, and then each one of these you'll see some are required, some are not. The more information that you could put in there, the better. Obviously, we're going to need to know who you are. Each engineering judgment that we issue is project specific. So we will need the project name, the project city, who's the responsible party. Sometimes it's the architect that's requesting it. Other times it's the installing contractor. Sometimes it's even the general contractor who's trying to figure out how to fix the problem. And then here's where you would put all of your different variable information, wall, or we were dealing with a floor in this case, concrete floor, thickness. Obviously, F rating is very important, 1, 2, 3, or 4 hours. And then again, any of the special conditions. So we may reference CAJ 1240 here and just put special condition, larger pipe size, maximum 36 inches. Pictures are always great. You can drop a file right in there. And this is also very mobile friendly, so you can do this entire process from your phone. You hit submit, and within 24 hours, you'll get your engineering judgment back. So that's kind of how you request a judgment very easily. We always, once again, recommend that you find a system here first. See if you can find it under system search. It's very easy with some of these drop downs to do that. So that's how you would do your system search and your engineering request. So I'm going to go ahead and try to just put a couple slides back up here while we get Keith some feedback. Let's see from current slide. There it is. Okay. And then I think we have a couple questions that are ready to go. One more QR code for you, or actually one more until later. But this will take you over to Keith's LinkedIn post for this webinar. So if you enjoyed what you heard, leave Keith a little bit of feedback, and then we're going to pick one or two people that leave feedback, and we'll give you one of the great prizes that you see up there. We have some pretty cool swag, some embroidered bags for you. So Keith, you ready for some questions? Christina, do you have something ready to go?
Yeah, we have a couple that came in. First question is, are definitions provided by the IFC typically acceptable to the AHJ?
My experience, yes. A lot of people know and refer to the IFC. And, the definition is not official. It's not in the code like that, but I think it's a very good one.
All right, Keith, I know there was a question the last time about OSHPD, and there were some questions on if they have some different, if they're accepting the EJs. What did you find out about that? I know you looked that up for somebody last time.
Yeah, I mean, OSHPD does have their own guidelines for engineering judgments, and you can find those online on their website. They're very, very similar, though, to what IFC and others have defined. And whether or not they need or require an engineering judgment to be stamped, or if they draw the line and say no EJs, that's up to each individual and each project.
If a PE stamp on an EJ is needed, what is the typical lead time for obtaining such an EJ?
Good question. Of course, it depends on the firm and the person who's doing it and how busy they are. But typically, a day or 2 or 3. That's been my experience.
Okay. Keith, what jurisdiction, or maybe what jurisdictions in your experience do not allow EJs?
Well, you saw that list. Oh, sorry, that was for stamping. The ones who don't accept EJs, typically these have been in California. California State Fire Marshal has been the most notable one. Not a lot of others that I know of who will just say no engineering judgments, but there are other pockets and other projects where it's happened.
During construction, the architect is observing construction, not inspecting. How or who determines when an EJ is necessary? How is it being monitored?
I'm sorry, could you repeat that, please?
Sure. During construction, the architect is observing construction, not inspecting. How or who determines when an EJ is necessary? How is this monitored?
Well, it's everybody's responsibility. If an inspector doesn't catch it, that doesn't relieve you from meeting the code. And the code says if there is no tested system, then you need to seek an engineering judgment. So it's it's on all of us to do the right thing there.
All right, Keith, next one. I'm going to kind of read this a little different than it's written. They kind of asked how come common EJs have not been developed into tested systems. I think they kind of are. Once I know as a manufacturer, when we see a lot of EJs that seem to be the same, that kind of forces our hand to test sometimes. Do you agree with that statement?
Exactly right. Yeah, we go through, as a company, we go through engineering judgments on a regular basis and see which ones are coming in repetitively, and then try to get that into our testing program. Exactly right.
Yeah, that question specifically mentioned some membrane penetrations, and I've seen a lot of new systems testing just for membranes, so I believe that UL is kind of requiring manufacturers at this point to test different membranes, correct?
I don't know if they're requiring that, but we have increasing number of systems for membrane penetrations.
Right.
We could use more. I think the whole industry could use more, just for clarification.
Yeah, so Joseph, great question. You can check out our system search there and see what type of membrane penetration systems we have. So thanks for the question.
Next question. How often have EJs done for government Air Force buildings, and are they acceptable?
I don't have a specific example I can think of from an Air Force base, but the process, I believe, will be very much the same. And then it's up to the authority having jurisdiction, whether they accept it and how.
Just kind of reading through some of these, Keith. Someone saying, I believe NFPA requires the architect to monitor the installation. Is that correct?
In NFPA?
Yeah, I don't believe so. I haven't heard that one.
I'm not aware of it. Doesn't mean it doesn't exist.
Right. Typically, the architect wouldn't be monitoring the installation. Now, that would fall on an inspector. I know a couple questions came in about third-party inspection, and I'll just kind of reiterate what I typed in there. But as of 2012, the IBC does require special inspections on certain buildings, high rises of 75 feet or higher, or certain risk category 3 and 4 buildings where there could be explosive type materials in there. So these are, things where the special inspections are required, but that is, again, enforced by the local authority having jurisdiction and their ability to enforce that. So I hope that answered that question. Christina, next one.
This one's a good one. Have you ever done EJs and combined your STI product with another manufacturer's product?
No, we don't. We won't do that because, especially if materials come in contact with each other, we don't know the chemistry of another manufacturer's product, and we don't want any kind of incompatibility. So, no, that part is avoided. There's no question that sometimes products do overlap, though, in the field when you have penetrations close together, or maybe 2 joints that meet vertically and horizontally. Even penetration overlaps with a joint. These things do happen. And those compatibility issues are a problem because neither fire stopping company will warranty the other, so to speak. So no, we avoid mixing manufacturers.
Yeah, definitely don't mix manufacturers. When you get an EJ revised, does that make the previous EJ void for that project?
It should. If you made a revision, it was for a reason. There must have been a correction or something was left out or whatever. So, yeah, always use the latest version. We go by letters. So if you have an EJ number and then it says A, B, C, D, just use the most recent version.
Are there multiple EJs for the same applications, different products?
There's definitely multiple EJs for the same application, especially because sometimes the exact application comes up on different projects. So it can be reused as long as it's reevaluated for the new project. I hope I'm answering the question, if I understood it right.
Yep. We have time for one more here. If an EJ is required that would include modifications to the structure, like a wall that needs to be upgraded from non-rated to rated, would you, our field engineer, work in tandem or even recommend a structural engineer to help out in that situation?
We could. I think a lot of architects are quite good with assemblies, fire-rated assemblies. So if there does need to be modification, then it's very possible the architect could do that. Or, there's usually a structural consultant on each project, and he or she could be consulted on that. That's a little beyond the fire stopping scope.
A little bit. All right. That looks like that's about all the time that we have for questions. Keith, thank you very much. That was a great job. And before I let everyone go, I just want to let you know about a couple other trainings that we have coming up here. This is a webinar that we're going to be putting on next week. This is going to be the recording of our FIT Level 1 training. This is the course that is worth 3 credits for AIA and 3 BICSI CEC credits. So that's happening next Thursday from 12 to 3 p.m. And this is a great course to get a little bit further in, product selection, UL systems, and things like that. So we'll keep it nice and fun and interesting. So if you're wanting to sign up there, just click that QR code. That'll take you over to the registration page. And then our FIT Level 2, we're right into that's time of the year where we're going to start doing our Level 2 course. This is a 2-day course. We typically do it at our corporate headquarters, but due to the conditions that are out there, we're going all virtual, at least for the April and the May sessions. So if you want to go even deeper, again, this will give you the ability to be a trainer if you so desire, or if you're looking for those AIA or BICSI credits, you can get 8 and 6 respectively there. So check out one of those great trainings coming up. And then once again, Keith, thank you very much. You want to say goodbye to everybody?
Thank you very much, everybody, for your time today. I know you're coming in from all different time zones and places, and really appreciate you spending the last hour with us.
All right. And Christina, just one more time for everyone. Let them know when things are coming.
Yeah, we're going to be sending certificates out to everyone who attended at least 75% of the webinar, so you can self-report. We will be reporting the AIA credits for those of you who are part of AIA, and we'll be sending a recording out with those certificates as well. So just give us 7 to 10 business days, and we'll get that out to you.
All right. Thanks again, everyone. Have a great day.